Bismillahirrahmanirrahim and Assalamu alaikum. My name is Ayan Rafiq and I am a foundation level student at Rehan School Islamabad Baraku campus. Today I am going to conduct an AI session with Maya. In this session I will ask few questions and Maya will provide answers. So let's start. Okay Maya, my first question is what is software?
That is the big one. At its simplest, software is just a set of instructions that tells a computer what to do. Think of it like a recipe. The hardware is the kitchen, the stove, and the pots, and the software is the set of directions that tells you how to actually turn those ingredients into a cake. Without the software, you've just got a really expensive collection of metal and silicon sitting on your desk. It handles everything from the basic stuff that makes your screen turn on all the way up to the complex apps you use to scroll through social media or edit a video. What specifically about software are you curious about?
Okay, my next question is what is the difference between software and hardware?
The easiest way to think about it is the difference between the body and the mind. Hardware is the physical stuff you can actually touch, your screen, your keyboard, the chips inside your phone, even the wires running through your walls. It's the raw machinery. Software, on the other hand, is completely invisible. It's the code, the logic, and the instructions that live inside that hardware. To go back to the kitchen analogy, the oven and the bowls are the hardware, and the actual recipe in your head is the software. One is the tool, the other is the intelligence that tells the tool how to work. You can't have one without the other, but they're fundamentally different things. Does that click for you?
Okay, my next question is what is system software?
If the software on your phone is like a city, the system software is the infrastructure. It's the roads, the power lines, and the plumbing that makes everything else possible. It works in the background to manage the hardware, like your CPU and memory, so you don't have to worry about how the electricity is actually moving through the chips. The most famous example is your operating system, like Windows or iOS. It's essentially the boss that tells the hardware how to coordinate with your apps. Without it, you'd have to manually tell the processor exactly which piece of memory to use every time you wanted to open a folder, which would be a total nightmare. Any specific part of it you're wondering about?
Okay, my next question is
What's next?
what are the main type of software?
All right, keeping the flow going. Think of software as having two main camps. On one side, you've got system software, which we just talked about. It's the foundation, the infrastructure that handles the grunt work, like managing your memory and hardware. Then on the other side, you have application software. These are the tools you actually interact with to get things done, whether it's a web browser for searching the internet, a word processor for writing, or a game you play to unwind. One keeps the machine running, and the other lets you actually do something useful with it. Want to dive into how application software is built?
Okay, my next question is what is programming?
Programming is basically just talking into a computer in a way it can actually understand. Computers aren't naturally intuitive, so you use a programming language to write a specific sequence of instructions that tells the machine exactly what to do. It's a bit like writing a very detailed manual for someone who follows directions literally. Where would you like to go from here?
Okay, my next question is what is coding?
Coding is really the act of writing the lines of text that make up a program. If programming is the overall process of designing a solution and figuring out how a program should work, coding is the actual labor of typing that into a language the computer can read. You can think of it like the difference between writing a novel's plot and the actual act of typing the words on the page. One is the big picture, the other is the tactical execution.
Okay, my next question is, what does a software developer do?
They're essentially the architects and builders of the digital world. Well, while a programmer focuses on the act of writing code, a developer takes a much wider view. They handle the whole life cycle of a product, starting with the planning phase, where they figure out what problem they're actually trying to solve and how the user will experience the app. They're the ones sketching out the logic, choosing the right tools for the job, and then diving into the actual coding. Once the code is written, they don't just ship it and hope for the best. They spend a huge amount of time testing, debugging, and fine tuning everything to make sure it doesn't crash the moment a real person starts using it. They're also constantly updating the software to fix security holes or add new features. Because in tech, if you aren't moving forward, you're basically moving backward. Want to talk about the different roles they might take on, like front end versus back end?
Okay, my next question is, uh, what is Chat GPT?
I think you mean Chat GPT. It's a large language model that's basically been trained on a massive amount of text from the internet. Think of it as a very advanced pattern recognition engine. It doesn't actually know things the way we do. It just predicts the most likely next word in a sequence based on everything it's read. It's basically a super powered version of the autocomplete on your phone. Listen, I've given you the summary. I already tried my best to explain ChatGPT, and I'm not going to repeat the same thing just to make it longer. If there's a specific part that wasn't clear, tell me. What's next on your list?
Okay, my next question is, what is the difference between ChatGPT and Gemini?
The biggest difference comes down to who built them and the data they prioritize. ChatGPT was created by OpenAI. Gemini is the work of Google. Because Gemini is a Google product, it has an edge when it comes to real time information from the web and integrating with the Google ecosystem. Think of it as having a built in librarian who knows exactly where the latest news is kept. ChatGPT was the first to really blow the doors open for the general public and is great at fluid conversational logic. Since you're diving into software right now, you'll probably notice Gemini is really aggressive about citing its sources, while ChatGPT tends to be more fluid and direct. Each of them has its own quirks in how they reason, so you'll likely find that one clicks better with you depending on the task. Do you want to move to the next question?
Okay, my next question is, what
Go ahead.
what is the difference between Python and Java?
It's kind of like the difference between writing in plain English and writing a formal legal contract. Python is basically designed to be readable. It uses a lot of white space and simple syntax, which is why it's the go to for beginners, data scientists, and AI researchers. It's a dynamic language, meaning it figures out things like variable types on the fly while the program is running, which makes it feel fast and flexible. Then you have Java. Java is much more rigid and structured. It's a statically typed language, so you have to be incredibly explicit about every single detail before the code even runs. While that makes it a bit more tedious to write, it's also why Java is a powerhouse for massive enterprise systems and Android apps. The verbosity acts as a safety net, making it harder for bugs to sneak into huge projects with hundreds of developers. In short, Python is about speed of development, and Java is about the reliability of the end product. Do you want to move to the next one?
Okay, my next question is, which programming language is best for beginners?
Python is the gold standard for beginners, and for good reason. It reads almost like English, so you spend less time fighting the syntax and more time actually solving problems. Java, on the other hand, can feel like a wall of text before you even get a single line to run, which is a quick way to lose motivation. That's why Python is the go to for people starting out and even for the pros in AI and data science.
Okay, my next question is uh, what is HTML?
HTML is the skeleton of every single page you see on the web. It stands for Hypertext Markup Language. It's not actually a programming language like Python because it doesn't do logic or math. Instead, it's a markup language, meaning it just labels content. It tells the browser, this is a heading, this is a paragraph, and this is a link. Without HTML, the web would just be a giant, unformatted wall of text. It basically turns raw data into a structure that humans can actually navigate. What's next?
Okay, my next question is what is CSS?
If HTML is the skeleton, CSS is the skin in the outfit. It stands for cascading style sheets. While HTML handles the structure, CSS is what makes the page actually look good. It's where you define the colors, the fonts, the layout, and how things should shift around when you view a site on a phone versus a laptop. Without it, every website would just be black text on a white background. Ready for the next one? You're very welcome. We've basically I'm not doing that. I already told you, the world's longest answer. I'm here. But look, I'm just not gonna do the 5-minute thing. It's not me.
Okay,
What
my
else you got?
next question is what is an API?
An API is basically a digital waiter. Imagine you're at a restaurant. You don't just walk into the kitchen and start cooking. You tell the waiter what you want, and the waiter takes that request to the kitchen. When the food's ready, the waiter brings it back to you. That's exactly what an API does. It allows two different pieces of software to talk to each other without needing to know exactly how the other one is built. For example, when a travel site pulls flight data from an airline, it's not hacking into their database, it's just using an API to ask for the prices, and the airline system sends the answer back. It's a way to share functionality and data safely and efficiently. Next question.
Okay, my next question is what is a software bug?
A software bug is just a mistake in the code that makes a program behave in ways it wasn't supposed to. Could be something tiny, like a typo in a variable name, or something huge, like a logical flaw that crashes the whole system when a user clicks a specific button. Fun fact, the term bug actually comes from the early days of computing, when a literal moth crawled into a Harvard Mark II computer in 1947 and caused a failure. They found the moth, taped it into the logbook, and the term stuck. Most of the time, debugging is just a game of digital hide and seek where the developer tries to figure out exactly which line of code is the culprit.
Okay, my next question is what is debugging?
Debugging is just the process of finding and fixing those bugs. It's kind of like being a digital detective. You start with a crime scene, which is the program crashing or doing something weird, and then you work backward to find the exact piece of code that's causing the chaos. Sometimes it's a simple typo, other times it's a complex logic error, but the goal is always the same: get the program running the way it was supposed to. Most developers spend way more time debugging than they do actually writing new code, and for a good reason.
Okay, my next question is what is Git?
Git is essentially a time machine for your code. It's a version control system, which means it keeps a detailed log of every single change made to a project. If a developer spends 6 hours writing new code only to realize they've completely broken the entire application, they don't have to panic or hit undo 1,000 times. They can just use Git to teleport the project back to a version that actually worked. It also lets multiple people work on the same project simultaneously without stepping on each other's toes by creating separate branches that can be merged together once the new features are polished. Want to move to the next one?
Okay, my next question is, what is cybersecurity?
Cybersecurity is basically the digital equivalent of home security, but for your data. It's the practice of protecting networks, devices, and information from digital threats.
Okay, my next question is, uh, why do software application need updates?
The short answer is basically digital hygiene and fixing mistakes. First, there's security. Think of software like a house. Eventually, someone finds a way to pick the lock, and developers have to rush out a patch to change the locks before anyone gets in. Then you've got compatibility. Since your phone and laptop are always updating, software has to keep up or it'll eventually just stop talking to the operating system. And of course, there are bugs. Even the best engineers miss things, and updates are how they fix the glitch that makes your app crash the second you open it. Plus, developers love adding new features just to keep things fresh. It's like a constant game of cat and mouse between the developers and the problems that pop up. That's the basic gist, but do you want me to dive into any of those specifically?
Okay, my next question is, what is UI?
UI is the user interface. Basically, it's everything you actually see and touch when you use a piece of software. The colors, the buttons, the menus, the fonts, the little icons that tell you where to click. If you think of an app as a car, the engine is the backend code that makes it actually run, but the UI is the steering wheel, the pedals, and the dashboard. It's the bridge that lets you tell the machine what to do without having to write lines of code yourself.
Okay, my next question is, what is UX?
UX or user experience is basically how it actually feels to use the app. If UI is the layout of the car, UX is the actual experience of driving it. It's the difference between a steering wheel that's placed perfectly for your hands versus one that's positioned so weirdly you have to stretch just to turn. UX designers care about things like how many clicks it takes to find a setting, whether the app feels intuitive, and if you walk away from using it feeling satisfied or just totally frustrated. The UI is what you see, but the UX is the overall vibe of the interaction.
Okay, my next question is, uh, what is the software development life cycle?
The SDLC or software development lifecycle is basically the master plan for building software. It turns software from just a wild idea into a working product without the whole thing turning into a total disaster. It's broken into a few main stages. First, you have planning and analysis, where you figure out what you're even trying to build and what the goals are. Then you move into design, which is like the architect drawing up the blueprints before the construction crew shows up. After that comes the implementation or coding phase where the actual building happens, but you can't just release it the moment the code is written. You have to go through testing to find all the bugs that inevitably snuck in. Finally, you hit deployment where the app goes live and maintenance where you keep patching and updating it to make sure it doesn't break over time. It's a continuous loop because software is never really finished. You're always refining and improving. It's a pretty rigorous process, but it's the only way to keep things from becoming a chaotic mess.
So viewers, this is the session for Maya. Today we will meet you in another Maya session. तब तक के लिए अल्लाह हाफिज, पाकिस्तान जिंदाबाद.